Because I'm on 4.1 already.
Yeah, I'm on 4.1. Are we on 4.1 today?
A little more to the
I
left.
think we are. Are we on 4.1?
Is that too bad? Go to work?
What do you think?
Yeah, that'll work, because he always slides it over to that one.
That works, yeah.
Did I understand it? All right.
Questions on 3.5?
All right, guys. So we got our first question of the day. Lewis.
Let's see.
3.6. Which one was it again?
3.5, number 27.
3.6 or 3.5?
It was 3.6.
Oh,
27.
I'll go second.
3.6?
We did 3.5 on it, didn't
We finished up at 3.6.
Oh yes.
we? Oh, that's right. Yeah, I am thinking the question, the second thing.
Dude, come on.
I'm on the wrong section.
All right, guys. So
I'm staring right
let
at it.
me build up this one, guys. It's related to a problem that gives us so much trouble, and I think in the lecture the other day we actually did a problem like this. Believe it or not, there was more graphical. So tell me this. Holy
What the? Marker's committing suicide again?
dead. If I give you this here, like that. All right, there you go. How could I graph that? What would you start to do?
You would make an X and Y table.
You can make an XY table, love it, right? So when you plug in, let's say you plug in a 1, how would I write this to start doing that?
F times
F of
1
1
equals 1 squared.
Beautiful, and then you plug it in. So the whole idea of functional notation is when you put something in there, you are replacing x with it. It's just substitution. So you just replace x with what you replaced x with. Right?
1 plus 3.
4. Good. What point does this graph go through?
It's 1/4.
The only one we know so far is 1/4. There's many, many, many other points, right, that you can make. But it definitely goes through this point because I see this work, right? So if somebody gave me, they said, oh, I see some points on a graph. They look like this here, blah, blah, blah. And they said, okay, what must f of 4? What must that be?
Minus.
It's got to be freaking -2, right? Because what did the person do? So over here, we did it. We plugged something in, we saw what came out, we see what point, blah, blah, blah. Over here, somebody gives me a collection of points. And they say, okay, what must f of 4 have been? Well, they've already done the work. Here's the input, there's the output. So what must f of 4 have been?
-2.
The thing that freaks me out is they don't even tell me what f is. They don't tell me what f is. What am I supposed to do? That's fantastic. Somebody else has to worry about that. Look, I just see the work they did. Yay! I got no work to do. They did it. When they plugged a 4 in, they must have got a -2 out. When they plugged a 0 in, they must have got a 3 out, because that's where they put the point.
Oh, I see now. It's easy.
Right?
Yeah.
So visually, let me see. If they give you a graph, real quick, I think I said this the other day when we were doing the domain and range. So if I have a graph like this, let's not make it too freaky. Again, sound effects are optional. Can anybody tell me what f of 1 must be for this?
2, right?
Because that's the output. That's where it is. And that freaks people out. And I understand, because you're used to having the function. You're used to that. But realize this is awesome. Somebody's already done the freaking work. All somebody else is asking is, what did they get out when they did the work? Well, they must have gotten a 2 out. Why? Because that's exactly where the thing is. That's what the output is there. For an input of 1, what's the output? 2. That kind of question is easy as hell. It's just a matter of when you first see it, you're like, what the hell do they want from me? I got nothing to work with here.
Okay,
So we did assignment 3.5.
F of 0 is 1 then?
Yeah, f of 0 would be 1. That's awesome. I didn't really mean that, but yeah, f of 0 would be 1. What's f of -1? Trying to be anyway.
0.
0. Because that's the output there.
Right.
It's supposed to be.
So what you're saying is like if the f of 1, that'd be x. you know,
Yeah, that must be what X was.
yeah,
And when they make X1, what must they have gotten out? They must have gotten a 2 because that's where they put the point.
yeah.
So see how these are really the
Okay.
same?
Mm-hmm.
This is visually a bunch of points. This is a list of a bunch of points.
Okay.
I can still ask you the same questions on both. You just have to look and see, for that input, what was the output? For that input, what was the output?
So on that question would be 4, would be output.
Yeah, on 27 specifically then,
4.
yeah, you see they say what's f of 1, and there's, if you look up there, there's a point that's 1,
4.
4.
So it's gonna be.
So f of 1 must have been 4, 1, 4.
Yeah. 30, yeah.
Is that cool? You guys see that? Because when you graph a line or a curve, what are you graphing? You're graphing all the answers. So of course, if I see a graph or a collection of points, it should be easy. Those are all the answers.
It's gonna
And I
be,
can just go pick out whichever one I want.
it's gonna be in a parabola.
So it means this is X,
Oh yeah,
and
this is
Y.
Y. Yeah.
This is X, this is Y.
Exactly. This is the input X, this is the output Y.
Output.
Yeah.
Yeah.
So
But
then
it's easier than
F is always related to X.
Well, you plug X into the function, and then the Y is what pops out.
It's never f of y.
Unless
It's
you
just a
wanted
six.
to make it that way.
Right.
I mean, we're not going to make it freaky yet, but remember I told you last time we could have a cost function? Cost of making so many widgets,
Yeah.
right? Widgets used to be those imaginary things business people made, and they talked about how many widgets do I have to sell to break even, you know? So that's the cost of that. You could also talk about like a velocity at a certain time, couldn't you?
Yeah.
How fast I'm going, the velocity at a certain time.
Which determines your speed.
So for us right now, what's the input X? What's the output Y? Always for right now, just so we get used to the ideas. Later, the letter doesn't matter really, right?
You
Does it
just-
really matter that we say it's X?
You just
No,
plug the
it could
input
be
into
Y
that
and X, the other way, who cares? But just to keep it so we can learn the concepts, we're going to keep it X and Y, right? Thank God. I don't want to get it all muddied up. Okay.
Number 56, please. 256, page 256. Number 56.
Oh, okay. 56, they give you this graph of these light bulbs. And like one of them's wow, the other one's wow.
Which page was that? 35?
This is page 256,
It's a wild looking app, that's for sure.
number 56. So this is actually exactly what we just talked about. They say, like part A says, what's f of 2600? You could do it, Jeff. There you go. Minus g of 2600. First off, which one of these is f?
Incandescent.
Long line.
Careful now. Read it
F is
through.
the years.
No, careful now.
Incandescent bulb.
F is the function for,
And that's,
Yeah.
that's
right? F is the function for incandescent.
Light bulb.
yeah.
And that's the top one.
Gotta do the blue line.
That's the F. So obviously,
G is
process of
the-
elimination, this must be G.
Energy efficient.
And they tell me G is the energy efficient bulb, right?
Right.
Makes sense, the one that uses less energy?
Cotton thread.
Uh-huh.
How we doing? So they say, so down here, you see how this scale goes up to 2600 here?
Yeah.
That's a
Right.
big graph, then. 2600.
2600 here, that'll make it easier to see. So at 2600, can you see what G is? And
Yeah.
at 2600, can you see what F is?
F.
And is that all they asking?
Yeah.
What is F of 2600? Can somebody estimate that for me?
150?
Yeah.
Yeah, I'd say like 150. Can I say that? At 2600, where does the F function go? It goes up to 150.
So up
Roughly.
2600 over 150.
And what's the G function do?
40.
About 40?
Yeah.
You see. Yeah. And that's all we're asking now. What's 150 minus 40? Oops. 150 minus 40. So that's exactly related to what we just talked about. They gave me the graph, they've done all the work, they've done all the plotting. I just have to go see where they put the point. What's F of 2600? It's going to be 150. G of 2600? It's got to be 40.
110.
110. And of course, that's the difference in watts used between those two types of bulbs.
I see slope going on there.
No way! Alright. Yes?
Section 3.5, number 27.
Oh, okay.
Because the graphic I got fine, it's just I was just stuck on the domain and range.
So when we do a chart,
You would?
X and Y, yeah.
Make a table.
Make a table, yeah.
Exactly, yeah. So you can make a table of values, right? And I normally put in some negatives and put some positives in, right? So whenever you're not sure about a function, you should definitely put some negatives and positives. But this is one function we definitely know what it should look like at the end. What it's going to look like. A parabola, a U shape, right?
Yeah.
Nice curve.
It's because of the second.
Because of the second power. In fact, any even power will come out looking like
U.
so y equals x to the 10th will be a really steep U. Yeah.
Close together.
It goes up really quickly,
For.
right? Because 2 to the 10th power is damn big.
Oh, okay.
So x to the 10th would go up really quick.
I was ending up with a straight line. Okay, I see what I did wrong.
So now what do we get when we plug in a -1?
5.
Yeah, -1 squared plus 4 is 5. You plug in a 0,
4.
plug in a 1, 5. Plug in a 2,
You get
2 squared is 4 plus 4 is 8.
It gets big quick, kind of.
Right? So where does it look like the turning point is?
it would be
At that 5
You
point.
started from
the
4.
yeah, the 5 point, right? Or
1 and 5 and 1 and 5.
1.5
Let me
negative.
catch up. So -1, 5, right? -1, 5.
This would be an upside down parabola.
0, 4.
Oh, that's the point.
1, 5.
In between
So
the
see right there you can see it turning, right?
Yeah.
Yeah.
Sorry. 2, 8. So it's coming in like, make that big.
Like roller coaster. Right?
What are you doing there?
So
So make sure you can see in your table values, make sure you can see it going down then back up.
okay, I was
So you can
ending up.
find that turning point. That's the most important point on that parabola, right?
I guess I was still trying to make it a straight
So
line.
tell me
which I-
this. People got a little confused about what I've plugged in versus what the real domain is. Is the domain this?
No.
Isn't there a lot more than just that?
Yeah.
Yeah.
In fact, what is the domain?
All the
Infinity to
numbers.
infinity.
Yeah, I can use any number from here all the way through. I can use so the domain.
All of these numbers.
All in numbers.
Cool, I love it. Is everybody cool with that?
Yeah.
Is there any numbers I can't square? Of course I can. I can square any damn number I want to.
Yeah.
So I can use any x's. Now here's the trick. Domain, where's the domain start? I mean, not the domain, the range. Where's the range start?
Bigger than 4.
At 4, right?
Little dude walks, the first time he sees it is at 4. That's the very first output I get.
That's
So the
infinite.
range will start at
4.
4.
No.
And then how far out does it go?
Infinite.
Infinite.
Exactly.
Or I can say it's bigger than or equal to 4.
You could say, yeah, y. Remember we talked about
Yeah,
that before?
yeah.
Greater than or equal to 4. You can say that.
Yeah,
Yeah.
I can say it.
I think the book writes it that way. Interpolation's better here. I don't know why the book decided to go back to inequalities.
Interval notation would be what again?
That,
Y is
Right.
greater.
Or infinity?
Equal to.
So if you start with a 1 and a 2 with the x's, you're not done because you haven't found the turning point.
exactly.
Right?
Connecting, you might think it's a straight line.
Yeah.
That's what I
That's why
thought.
you got to find that turning point. You go, oh yeah, it turns. Right? Just like an absolute value, you got to find that kink.
So it's always good to use the -1, 0, 1.
Put some negatives, put 0, put some positives. Yeah.
Okay, so I guess that's where I went wrong. I tried to do a straight line. I'm like, well, how in the hell am I going to find domain and range with a straight line?
Well, a straight line is nice. I mean, if I have a straight line, what's the domain?
Everything.
Everything. What's the range?
Everything.
Everything. Right? As long as it's at a diagonal, that straight line has range is all real numbers, domain is all real numbers.
Or all functions.
No.
Those are functions.
These are functions, yeah. Oh, I'm sorry, you're asking if they're functions.
Yeah.
But not all functions have all real numbers.
Okay.
How do you get the range is 4?
The range isn't 4. Where's the range start?
At 4.
What are the first output? What's the lowest output I get?
4.
Is 4.
Okay.
I don't get anything lower than that, do I? So the range starts at 4
And then goes to
and
infinity.
it goes to infinity because I can make this as big as I want to.
Okay,
Yeah.
thank you.
And the range is Y.
Range is y.